Once again, hearty welcome to the video on answers to questions for revision, class 12 mathematics. 15 questions comprising MCQ, very short answer, long answer, and case study questions compiled at this video. The topic taken is application of derivatives. Let us move on to question number 1. A spherical balloon is inflated at the rate of 35 centimeter cube per second. The rate at which surface area is increasing. Now we have been given the rate of change of volume, the centimeter cube per second. Therefore, rate of change of volume is given. Therefore, let R is the radius, V is the volume, and S is the surface area of the spherical balloon. And given dV by dt is equal to plus 35 because it is inflated. Our V formula is 4 by 3 pi r cube, differentiated both sides with respect to t. We have been given dV by dt. From this, I can get what is dr by dt. It is 35 upon 4 pi r square. Let me go back to the formula for surface area. It is 4 pi r square. Once again, differentiating it with respect to t both sides. ds by dt is 4 pi into 2r into dr by dt. That is nothing but 8 pi r into dr by dt. dr by dt is already we have found. Substitute. You will get ds by dt is 70 by r. But they want what is the rate of change of surface area when diameter is 14. Be careful over here. They have given diameter 14, but we have to substitute for radius. Radius 7. Therefore, 70 by 7. Therefore, the answer is 10. It is 10 centimeter square per second. Therefore, option D is correct. Let us go to the second question. If the function is decreasing, then A belongs to. Now, we have to recollect what will happen if a function is decreasing in an interval. First derivative is less than or equal to 0 or less than 0 if it is strictly decreasing. Okay, then let us take f of x, differentiate it. Now you have been given that it is decreasing, therefore cos x minus a is decreasing. Therefore f dash of x is less than 0. For cos x minus a is less than 0, therefore cos x is less than or equal to a. Therefore the value of cos x is less than or equal to a. But do you know that what is the range of cos x? Cos x lies between 1 and minus 1 and its maximum value is 1. It is less than a, therefore a can be any number greater than or equal to 1. Therefore a is greater than or equal to 1. Therefore a is 1 to infinity. Therefore the option A is correct. Let us go to question number 3. Value of x for which f of x is maximum. Now we are finding the first derivative. We are equating it to 0. Then x is equal to 1 by 2. Now we are finding f double dash of x. We are getting only one critical point. We are finding the f double dash of x. It is minus 2. Therefore, f double dash of x will be always less than 0 for any value of x. Therefore, at x is equal to pi by 2 also, it is less than 0. Therefore, it is the maximum. Less than 0. Therefore, second derivative less than 0. Therefore, it is maximum when x is equal to 1 by 2. Therefore, the option is B, 1 by 2. Now, we are looking at the graph of the graph of it is maximum at the point 0.5. Maximum value is 0.25. Well, let us go back to the question number 4. The maximum value of the function, modulus function. Be careful with this. Therefore, what will happen to modulus always? Start with that. Modulus is always greater than or equal to 0. Now, there is minus there. Then what will happen? Greater than or equal to 0 will become less than or equal to 0. Add 3 to both sides. Therefore, the f of x is less than or equal to 3. Therefore, what is the maximum value of f of x now? It is 3. Therefore, all modulus function you have to follow this technique. Therefore, let us see the graph of it. Now we are seeing that the maximum value where the f of x reaches is 3. You can see over here the graph. Let us go to the problem number 5. Stationary point. Now you remember what do you mean by stationary point? That is a point where the function is neither maximum nor minimum. That is the meaning is the point where the derivative is equal to 0. Okay, now let us see stationary point is a point where the derivative is equal to 0. Take y is equal to x power x. You have to differentiate it, but cannot do it because it is a function power function. Take log on both sides. It is a logarithmic differentiation. We have done it. And we are taking what is dy by dx. Now we are equating dy by dx to 0. X power x cannot be 0. Therefore, 1 plus log x is equal to 0. Log x is equal to minus 1. Raise the power to e on both sides. E power log x is e power minus 1. Therefore, x is equal to e power minus 1, which is 1 by e. Therefore, the value of x is 1 by e. The option B is correct. Let us go to assertion and reasoning. Here, all of you know the technique. We have to check whether the assertion is true or false. Then we have to check whether reason is true or false. Then we have to check whether the reason is used for the assertion, proof of the assertion. And in assertion, it is given that the function is decreasing. Let us check out assertion x minus sin x. You will find the first derivative. But we know that cos x always lies between minus 1 and 1. Therefore, 1 minus cos x is always greater than or equal to 0. Therefore, x minus f of x is increasing. Increasing. Therefore, now we have to check out now the assertion is false. Therefore, it is decreasing given. But anyway, I think it is not decreasing. It is 1 minus cos greater than or equal to 0. That is for x from 0 to pi by 4. It is increasing. Therefore, assertion is false. Now, let us go to the reason. A function is decreasing when f dash of x is less than 0. Yes, it is correct. But reason is true. Therefore, the option is A is false, but R is true. Therefore, from 0 to pi by 4, f of x is increasing. Well, now let us go to the second question, number 7. Maximum value is 1. Now let us find the maximum value. For that, what you have to do? You have to find the first derivative. I am equating it to 0 carefully. Only numerator will be 0. Therefore, x is equal to 1 by 2. All of you know how to get the maximum point. Closed interval 0 to 1 is given. Therefore, we have to consider the endpoints and the critical points. And we have to check the value of the function at these points. I am finding the value of the function at 0, 1 by 2 and 1. I am finding it. F of 0 is 0. F of half is 3 by 4 whole power 1 by 3. And f of 1 is 1. Out of them, the maximum value is 1 only. Cube root of 3 by 4 is not greater than 1. Well, therefore, assertion is true. Let us go to the reason. It is the definition of a maxima. That is how to find the maxima. It is being defined over there. Therefore, reason is true. And both A and R are true. And R is the correct explanation of E. Now we are just visualizing the maximum value of x into x minus 1 plus 1 whole power 1 by 3 from 0 to 1. You are seeing that its value is maximum value is 1. Okay. Let us go to question number 8. You have to find out for the curve is x increasing at the rate of 2 units per second. How fast they don't want how the y is increasing like that. They want how fast is slope of the curve. What do you mean by slope of the curve? For any function, dy by dx always talks about the slope. Okay, let us check it now. It is given that dx by dt is 2. Y is given. Slope of the curve is dy by dx. Therefore, dy by dx is equal to m is equal to 5 minus 6x square. Okay, that is we are differentiating it. Okay, therefore, m is equal to 5 minus 6x square. We have to find the rate of change of slope. Therefore, dm by dt we have to find. Be careful with this problem. We don't want to find dy by dt. Be careful with that. We want dm by dt. And it is minus 12x into dx by dt. Dx by dt is given. Therefore, minus 24x, but it is minus 72. What do you mean by that minus 72? It tells you that slope of the curve is decreasing at the rate of 72 units per second. You should know that whenever a negative sign comes, what is the meaning of it? The meaning is it is a decreasing. Show that this is increasing on R. We know that when a function is increasing, what happens? Its first derivative is greater than 0 or greater than or equal to 0. First it increasing. Okay, well. Let us try to find the derivative. I think very little bit lengthy. You have to do it very carefully and you have to simplify it. I have simplified it. I think all of you know how to simplify it. And remember, when you take the LCM and all, it is getting simplified fantastically. Okay. After that, you have to be very careful. Now you see, this is coming as 2 minus 1 upon 1 plus x square plus minus 1 upon square root of 1 plus x square. You have to split it into 2 to show that whether it is increasing or decreasing, whether it is greater than 0 or less than 0. For that, for 2, I am writing it as 1 plus 1. And it is written as 1 minus 1 by 1 plus x square as first term. And 1 minus 1 by root 1 plus x square as the second term. This is a technique. Now, when you see over here, the first 1 plus 1 upon 1 plus x square is less than 1 automatically because x is a real number. X square is always greater than 0. Similarly, 1 upon square root of 1 plus x square also will be less than 1. Therefore, 1 minus a number less than 1, 1 minus a number less than 1. Therefore, automatically it is strictly greater than 0. Therefore, it is a increasing function on R. Now we are seeing the graph of it. Actually, this graph is having two parts because this function is not continuous at some point. And you are seeing that the function is always going up. Therefore, it is an increasing function. Let us move on to question number 10. Find whether the function is increasing or decreasing. The same technique, but we have to see that in the given interval. We are not going to see in the whole R. We have been given an interval. We have to check in that interval whether the second derivative is positive or negative. Or we are finding f of x. F dash of x I have found. Now let us take the given interval now. 3 pi by 8 to 5 pi by 8. Therefore, x lies between this. Now, from this x, try to construct 2x plus pi by 4. Let us see. Multiply by 2. Then add pi by 4. You will get pi less than 2x plus pi by 4 less than 3 pi by 2. The meaning is this 2x plus pi by 4 lies between pi and 3 pi by 2. Can you identify it is in which interval, which quadrant? This interval, that is pi to 3 pi by 2, is nothing but the third. Yes, it is the third quadrant. What will happen in the third quadrant? In the third quadrant, sign is always negative. Therefore, f dash of x minus sign will be greater than 0. Therefore, f dash of x is greater than 0. Be careful with this problem. In this problem, f dash of x is minus sign of 2x plus pi by 4. Therefore, the given function is increasing in the interval. Can we look at the graph of it? Fantastic. This is the graph of it. You are seeing that from 3 pi by 8 to 5 pi by 8. You are seeing in the graph. See the x-axis. From 3 pi by 8 to 5 pi by 8, the curve is going up, up, up. Therefore, it is increasing. We have to find the local maxima and local minima. You know the technique of it. You have to find f dash of x. We have to equate it to 0 and find the critical point. That is step number 1. Let us find it now. F dash of x equated to 0. We are getting sin x is 1 by 2 and sin x is uh, sin pi by 6. Therefore, we have to check out where sin is positive. All of you know in the sin is positive only in the first and the second quadrant. First quadrant, the angle will be less than 90. In the second quadrant, the angle will be pi minus. Therefore, it will be 180 minus. Okay, therefore, it will be pi by 6 and pi minus pi by 6. Therefore, two values will come. One is pi by 6, another is 5 pi by 6. Okay, now let us now find the second derivative. Now let us find the value of second derivative at pi by 6. Automatic, it is less than 0. Therefore, local maxima. When you take 5 pi by 6, when you find the value of the second derivative, it is greater than 0. Therefore, point of local minima. Fine. Now you check out the problem. If they ask the values of local maxima minima, you find it. Otherwise, no need to find. Okay, well, now I think we are going to the graph of it. This is the graph of it. You are finding that at pi by 6, it is having a maxima. At 5 pi by 6, it is having a minima. I think very clear from the graph. Well, now again, previous problem was local maximum minima. Now we want absolute maximum minima. Fine. Same thing. You have to find the critical point. That is step number 1. Finding f dash of x, equating it to 0. Here we are getting two values. Sin x 0 and cos x is minus 1 by 2. Sin x is equal to 0 and cos x is minus 1 by 2. Sin x is equal to 0 means x is equal to 0. Now remember, now we have to get cos x is equal to minus 1 by 2. The value of x should be in the first and the second quadrant. That is 0 to pi. Therefore, cos x is minus half, which implies cos x is equal to minus cos pi by 3. Cos x lies in the second and the third quadrant. Cos is negative only in the second and third quadrant. Therefore, it should be pi minus pi by 3. Therefore, 0, 2 pi by 3 and pi. Therefore, sin square 0, the value we are finding. F of 0 is minus 1. F of 2 pi by 3 we are finding. It is 5 by 4. F of pi we are finding. It is 1. Therefore, absolute maximum value is pi by 4 and absolute minimum value is minus 1. Let us see the graph of it. Very clear. We are just seeing that how it is going up and then coming down. Absolute maxima and absolute minima from 0 to pi. Minus 1. And 5 by 4 is 1 point something. You are just over seeing it over. Okay. Question number 13. It is a very long answer question. Sum of the hypotenuse and side of a right angle triangle is given. show that area is maximum when the angle between them is pi by 3. Sum of hypotenuse and side of a right triangle is given. What is the meaning of given? It is a constant. Okay, let me take a right angle triangle now. Let me call it as x, y, and L. L is the hypotenuse, x is the base, and y is the height. Area is half into xy. All of you know half into base into height. Now, area I am writing it in terms of x and L. Now, it has been given one sum of the hypotenuse and side of a right angle triangle is given. But I will take for my convenience L plus x is constant. Therefore, L plus x is equal to k. Therefore, L is equal to k minus x. Now, let us substitute it in the area formula and I am simplifying it. I am getting the formula of area like this. But remember, the formula of the area is having a square root. Whenever you are having a problem where it is not having any number, all are unknowns to you, if you want to differentiate it, better square both sides and differentiate. Always remember, when area A is maximum or minimum, A square also will be maximum or minimum. I have found A square. Now A square I know. Now I am finding its a derivative and I am equating it to 0. I am getting k is equal to 3x or x is equal to k by 3. Therefore, x is equal to the constant k upon 3. Now I am finding the second derivative. In the second derivative, I am putting the value x is equal to k by 3. I am getting less than 0. Now there is no need to evaluate it continuously or fully. You have to simply check out or show that it will go to negative. Well, therefore it is a maximum when x is equal to k by 3. Now problem is not over. You have found that when x is equal to k by 3 and area is maximum. But what they want? They want when the area is maximum, what will happen to the angle theta. Now let us see what is the angle now. What is, you know, what is the formula for angle? Angle between the base and the slant height. Now cos theta is adjacent side by hypotenuse. We are having the expressed x and L in terms of k. Substitute it. You will get cos theta is equal to 1 by 2. Therefore, theta is pi by 3. Therefore, the area is maximum when the angle between the base and the hypotenuse is pi by 3. Let us go to question number 14. Show that the right circular cone of least curved surface area and given volume has altitude equal to root 2 times the radius of the base. Very easy question, but it is a very common question. But remember, what is given here? Given volume. For volume is constant. You have to assume volume is constant. R is radius, h is the height, and L is the slant height, and volume is constant. Therefore, I can represent h in terms of v. H in terms of v and r. Therefore, h is equal to 3v by pi r square. Let us go back to the curved surface area formula. It is pi or L. Pi into r into square root of r square plus h square. Now, I have expressed C in terms of R and H now. Now, H can be expressed in terms of R now. Before we go for that, as this expression is having a square root, let us square both sides. I am squaring them because maxima or minima is same for C or C square. Now, I am replacing H by 3V by pi R square. Therefore, 9V square by pi square R per 4. Simplify. You will get this is the final simplification of C square. Differentiated with respect to R. I have differentiated. Now equate it to 0. I will get the value of R square. That is 2R square is equal to H square or R is equal to H by root 2. But anyway, this actually we want it. But it is not over now. We have to prove that for this value of R, which is H upon root 2, second derivative we have to find, and we have to show that the second derivative is greater than 0 because this problem is a minima problem. Therefore, it is greater than 0. It's every term is positive. Therefore, curved surface area is minimum when R is equal to H by root 2, or curved surface area is minimum when H is equal to root 2R. Therefore, the conclusion is for least curved surface area, the altitude is equal to root 2 times the radius of the base. Let us move on to the question for case study. You have been given a square based tank. Therefore, x is the length, x is the breadth, and height is h. Therefore, we have to take volume as h square h, which is given as 250 in the question. Now, let us go to the first question. Total cost of digging. It is cost of the land plus cost of digging. Cost of land is already given there, 5000 x square, and cost of digging is 40,000 h square. Now the right hand side should be in the same variable. Therefore, replacing h by 250 by x square, then I have expressed it. Now here all of you can multiply that 40,000 into 6 lakh 25,000 and you can give the answer. But if you give the answer directly also, there is no issue. Now we have to differentiate it now. That is a question number 2. I am differentiating. Normal differentiation only. Now differentiation is over. Here also you can simplify. Now again question C. Find the value of x for which cost C is minimum. You know that we have to use a derivative test for this. Where I am finding dc by dx, I am equating it to 0. When I equate it to 0, I am getting x power 6 is equal to 10 followed by 6 zeros. Therefore, x power 6 is 10 power 6. Therefore, x is equal to 10. Therefore, at x is equal to 10, I am checking whether the second derivative is positive or negative, and it is positive. Therefore, cost is minimum when x is equal to 10. Let us go to the last question. Check whether the cost function expressed in terms of x is increasing or not. Already we have just proved the minimum value over there. Now we are checking increasing or decreasing. You check out this particular case study is having maxima, minima, then increasing function, decreasing, everything it has. Okay, well, c of x is increasing when the derivative is greater than 0. Now take the derivative, check out it is greater than 0, cross multiplied. Therefore, x power 6 is greater than 10 power 6. Therefore, x power 6 minus 10 power 6 is greater than 0. Now I am factorizing it. It is x cube the whole square minus 10 cube the whole square greater than 0. A cube minus b cube formula. A minus b into a square, a plus b into a minus b. A minus b into a plus b. Once again, this x cube plus 10 cube is always greater than 0. No need to check it. Therefore, x cube minus 10 cube only greater than 0. Again, once again, you use the formula a cube minus b cube. A minus b into a square plus 2ab plus, sorry, ab plus b square. Once again, x square plus 10x plus 100 is greater than 0. Therefore, ultimately, x is greater than 10. But what they want? They are asking to check whether it is increasing for x greater than 0. Therefore, it is increasing only when x is greater than 10. Therefore, the cost function is not increasing where x is greater than 0. Be careful. It is increasing for x is greater than 10. There is no issue in that. But we are proved that it is increasing only for x greater than 10. Therefore, it is not increasing for x greater than 0. Okay, well, uh, we will continue in the next video with the next topic.